Yeah, I guess. Okay, so I guess we're going to go ahead and get started. This talk is going to be about a community-driven S3 compatibility testing. My name is Frank Borich. I'm a software engineer at IBM. I work on a S3 compatible object storage application that's used in our public cloud as well as by many on-prem customers.
Hi, I'm Jeff Terrace. I'm a software engineer at Google, and I work on Google Cloud Storage, where we also have a S3 compatible API.
So start with a quick refresher on what cross-vendor compatibility is and why we care about it. In this context, it's just the ability for applications that use S3 to talk to object storage to function seamlessly across different storage solutions provided by different vendors. It's a nice... Oh, sorry, you can't hear me? Can you hear me now? Is that better? Can I get closer? Okay, great. It's a nice property to have because it enables all sorts of good things. This is not an exhaustive list, just some of the key ones. It prevents vendor lock-in. You can use it to avoid a single point of failure. It can provide freedom to react to compliance changes. You can use it to reduce cost. You can spread the load across multiple storage systems. And it can even lead to innovation because you're not limited by the properties of a specific implementation or a specific service deployment. SNIA has some good resources on this topic. There's a couple of webinars as well as a multi-cloud white paper. So if you're interested in this topic, I would encourage you to check those things out. Before we talk about the problem and the community we're trying to build around it, it's important to have a basic understanding of what the S3 ecosystem looks like currently. This isn't an exhaustive list, but it's complete enough. At the heart of it all is a de facto standard XML REST API. By de facto standard, we mean that it's widely adopted and used, but not formally recognized by any standards organization. You have a robust AWS service deployment for which the API was created, high quality documentation, AWS wrapper APIs in the form of SDKs, AWS client applications and tools, and then you have other S3 compatible object storage systems. There's also many applications around a wide variety of use cases and a large community. So all the SDKs are all open source, that kind of thing. And then there's even custom extensions and SDK tool forks around. So now that you have a basic understanding of the current ecosystem, what's the problem? So the problem is user-facing compatibility issues around this S3 ecosystem. And so like maybe an application was up and running just fine, and then it just breaks suddenly. And like maybe a change was made, maybe like a library was upgraded or a config parameter was tweaked or something. Or maybe no change was made and the application just performed an operation that wasn't supported by the storage system that you're talking to. And when this sort of thing happens, it's reliability that suffers. And we all know, like in storage, it's access to data, right? Being able to save off important data, that's critical. And so storage has to perform consistently well. And when these sort of things happen, that's what's impacted. Detection of the problems can be hard. Sometimes things are working on the surface, but under the covers, they're doing something unexpected. Root causing problems can be hard. Sometimes, like the end user just sees a 500 error and they have no clue where to start or what happened. Workarounds are often hard or not possible. Sometimes, the storage system you're working with just doesn't support an operation. And in that case, you're stuck or you have to get really creative. And it's very costly to everyone involved. So you can have unsatisfied customers, you can lose opportunities, and everybody has to spend a lot of time and energy root causing and resolving these sort of issues. Pretty expensive. So now that we have a basic understanding of the ecosystem and the problem we're trying to tackle here, we can talk a little bit about how the problems happen. And this is also not an exhaustive list, but just some things that we've noticed so far. So the S3 service deployment is a continuously changing reference implementation, and the documentation is not always accurate and it's not always 100% complete. And oftentimes testing is required to figure out what the expected behavior is. Server-side changes are continuously being deployed, and all of the SDKs and clients are continuously being updated, assuming those S3 deployment dependencies. But these same SDKs and clients are all being used against other S3 compatible systems that may or may not support the change. With the current versioning strategies and backwards compatibility criteria, like it's difficult to detect changes in a timely manner. Most of the changes are considered to be backwards compatible, and what seems like a safe backwards compatible change for the AWS deployment isn't for all the other S3 compatible systems with different levels of compliance. And there's no new major versions are introduced with these changes either, so they're kind of hidden. It's also important to recognize that the core I/O APIs are continuously evolving, so any change in this area just increases the likelihood of a issue escaping all the way to the end user. Third-party implementations typically support a subset, and the missing piece is often discovered when it's way too late after the application's been deployed and it's up and running. Applications often depend on a subset of the functionality, and that's usually based on what's current at the dev time. And so the application development teams just kind of do a best guess at what S3 compatibility is, and they kind of roll with that. And so with that approach, even like seemingly basic functionality isn't always guaranteed to work against all the different implementations. And finally, even following some best practices can cause issues. Some examples of this that we've seen are around ignoring unrecognized HTTP headers and query parameters, and also quick adoption of the SDK updates where you pull in a security to address a security vulnerability, and you end up pulling in some other default behavior that won't work against all the systems. So I'm going to turn it over to Jeff now so we can kind of talk about the community and what we're doing around this problem.
All right. Thanks, Frank. So Frank set the stage on what the problem is here, and so I'm going to talk about what we're trying to do to address the problem. So SNIA has what they call Plugfests, where everybody gets together and can test their client and server implementations. So in this case, we have the Cloud Object Storage Plugfest, where if you have an S3 client, if you have an S3 compatible server, we all get together and we test our implementations against each other to see what breaks or what works. We do compatibility testing to ensure interoperability. SNIA provides a vendor-neutral space where we can get together, and you don't actually have to be a SNIA member. So really anybody is welcome to join as long as you sign the NDA. The nice thing about being able to do this under NDA is that we can all be very candid and talk about low-level technical details without being worried that any reputational risk to your organization about finding bugs or reporting problems with your service. And you can go and discover these things and go and fix them before customers find them. When we get together for the Plugfest, we define a test matrix. So we build a big matrix with clients and servers and make sure that we're checking all the boxes to test them together. You don't even need to bring a finished product. So if you have a beta version of something, something that's still in development, you can even bring that and test it. And we've also been testing off-the-shelf open source applications. We're going to talk about that in the next talk, where you'll hear about the test tools that we're trying to develop and use. And we can all, some of the sort of, between test conversations that we all have, we find that we have a lot of shared experiences in developing in this space. And so you have conversations and you learn how other people dealt with similar problems that you might be facing. And we also brainstorm new ideas and new ways to deal with some of the problems that we're having. This is a picture from April of this year where we had a Plugfest. It was very successful. This was the second Plugfest. We had one before this in September of 2024, almost exactly a year ago. And we had very productive testing in both of these plug tests. The conclusion, or one of the conclusions that we came out of these Plugfests with, was that we need better tools. We need better test tools and better ways to collaborate. The existing tools that are out there for testing are really incomplete or hard to run or difficult to set up. And we all have our own testing tools that are sort of internal to our companies, that are proprietary and hard to run against other vendors, or hard to open source, or hard to extract from your internal business logic, which makes it difficult to share some of the pain that we've all been through writing these test suites. We talked about cross-vendor differences. So if you're trying to copy data from one cloud to another, the differences in the different implementations make it difficult to maintain data integrity. There's some links here for a webinar and slides from 2024. This is kind of a summary of all of the companies that participated in the Plugfests. The Plugfest, which you see on the left here, is open to all. Like I said, you don't have to be a SNIA member. On the right side, there's a description of a new test tools twig that just graduated from provisional to a full test or a full twig. The talk right after this, we'll be talking about this test tools twig. And I want to give a little bit of a summary for some of the things that we talked about this time. So we just, today is the last day of the Plugfest that we're currently running. And we have some sort of conclusions that, that have been coming out of it. So we talked about how the S3 reference implementation really is a moving target. The SDKs keep changing. Frank talked about this earlier, that the SDK behaviors keep getting updated and changing. And the REST API itself also keeps changing. New features keep coming. There's a lot of silent changes. So some things AWS does announce, some things they don't. Some things we are surprised to find when customers report, hey, I updated my SDK and something broke. We have found that there's a lot of inconsistencies between SDKs in different languages. So you can imagine, some of the more popular languages like Python and Java might have more robust implementations, where some of the less popular languages like PHP and Rust and Ruby and .NET, maybe some other less used languages might have less robust or less feature complete implementations, and we find behavior differences between those SDKs. There's really no roadmap for S3, right? I'm sure they have an internal roadmap, but it's not shared externally, so we don't know about upcoming technologies, upcoming features that they might be working on until they're released, right? So there's also a lot of interest in this because of this is being used in this as part of this whole ecosystem. There's a lot of features that others besides AWS are trying to work on. So some examples here: VectorDB, RDMA is a big hot topic. How do we run S3 over RDMA? We have structured data like Parquet files in S3 or S3 tables. People want to build key value caches on top of S3. There's connectors for Hadoop and Spark. There's S3FS, which just had a talk right before this. All kinds of features and technologies that people want to build on top of S3, but we don't have really a collaborative way to sort of develop these as open standards or open technologies that could allow interoperability. And one of the other things that came up was a performance test suite. So we all have our own performance testing, stress testing, load testing internally, but the tools for doing this in open source may not be complete or released at all. So we brainstormed ideas about, could we build a performance test suite that we could all share and be able to use on our own services. And this is kind of a call to action too, right? So what's up next? We're going to continue to do testing. We've been talking about doing remote testing, so we don't have to do it when we all get together and spend money on traveling. We can do some offline testing. We sign an NDA that maybe lasts for a year, and we can do online collaborative remote testing. But we will be back for SDC 2026 next year. Where we'll do another Plugfest, so we're hoping to have more members. We're welcome anybody that wants to join. So the SNIA developer website link is here. You can email Michael Horde, who's the chair of the Cloud Object Storage Twig. We'll add you to the Plugfest. There's a weekly Zoom call that we have if you're interested. There's a list here of sort of all the activities and things that we're working on. As always, we want you to join SNIA. If you're not a SNIA member, we do want you to join SNIA as well. And if you do that, you can get access to the test tools twig, where we're trying to develop some sort of open source test suite, which Adam will talk about in the next talk. I think that's the.
Membership.
Yes, membership. Yeah, no, I think it is supposed to be membership. You're correct. Yeah. Okay, I think that's it. Happy to take any questions. Yes.
Where's Amazon?
So the question is, where is Amazon? Well, Amazon is not currently a member of the Cloud Object Storage Plugfest. We welcome them if they're interested in joining. I don't know if you had anything else to add.
Do they have published release notes when they change their?
So the question is, does S3 publish release notes? There is a changelog, a sort of release notes as published. There's also there's a third-party website that tries to publish. They try to diff updates to documentation to produce a changelog. So that there is some sources for that. But again, that's only the things that are published or that are part of their documentation. There's a lot of internal sort of hidden, not really hidden by design, but sort of things that they maybe don't think is appropriate to document or isn't needed to be part of a release notes, especially because when you own both the reference server side implementation and the client side, you can do coordinated rollouts and not have to worry about compatibility. But as a third-party vendor, you're more interested in, there's an SDK update that depends on a server-side behavior that we haven't implemented yet. So so to summarize, there is a changelog, there is some release notes, but they're not, exhaustive. The question is, reverse engineering is required, and absolutely, yes. Yeah.
You stay inside the Amazon garden, right? How much backward compatibility do they maintain with the SDK? So how many revs back is going still?
Answer that one.
I don't know. The question was, how many versions can you go back for the?
I don't know about versions. Maybe like 6 months, a year.
It's not really well defined, or at least I haven't found any good definition for that. Typically what they'll do is they'll announce that they'll deprecate a very specific API and just leave it in the deprecated state for a long time, and then put some like future date on it and say, next year don't use it, or next year, like starting in all the new regions, like it won't be available, that sort of thing.
So for third-party clients, there are many S3 third-party clients. They're very hesitant to make changes to break those existing clients. But they will make changes in the SDK and be opinionated and say, you shouldn't be using this particular method anymore. New applications developed against that will not then use the functionality they want to go away. It's very much we don't want to break our customers, but we also want to be able to innovate.
Just to summarize for the recording, so the comment was that there's lots of third-party S3 clients. When S3 server-side changes are made, they're pretty good about not breaking backwards compatibility. I think there's probably clients that are 10, 15 years old that you could still run successfully. But the reverse is true, that as they're releasing new SDK versions, they assume that server-side deployments have been updated because they control the deployments. So they're willing to make changes that might break third parties because they don't own the third parties. It's not part of the S3 ecosystem.
So is this just a cloud problem, or is this beyond that? On-prem?
So the question is this just a cloud problem, or is it also applicable to on-prem? I don't know. What do you think?
I don't think that you can categorize it as like a cloud problem or an on-prem problem. I think it happens everywhere, and I think it's basically that it's all around Amazon's service deployment, which is a cloud, but then everything is trying to look like that. And so it's a problem with any system that's trying to talk S3, regardless of whether it's cloud or on-prem or hybrid or whatever.
I think I'll add one more thing on that, if Amazon had released like an S3 in a box, like an appliance that you could run in your own data center and they would not be able to control the life cycle of it, then I think you might see a different deployment model for SDKs. So, but because that doesn't exist, there's no Amazon-owned, on-prem service deployment. I think maybe that's why it's a cloud problem.
So, to what you just talked about, what about the Snowball and Snowplow series where they ship you basically Amazon in a suitcase and you're in some remote oil platform or some jungle or something where you don't have connectivity, there's no Amazon data center nearby. How do they control that?
Okay, so the question is about, so the question is about Snowplow service where you can run a AWS deployment somewhere remote that doesn't have internet connectivity. I don't have experience with that. It's managed. So there's probably some coordination between whoever deploys it and Amazon about keeping it up to date.
For Snowball, they're shipping the product and they update that software periodically. And for Outpost, it's managed, so they push software updates.
Okay, so to summarize the comment is that Amazon can ship updates to the Snowplow container that you run. So imagine they probably have an inventory of where their deployments are so that they know that they're updated before making SDK updates. It's my guess, but it's conjecture.
So I'm curious, if you looked at lessons learned from other clone wars in the past, like x86 battles where there's a bunch of Cyrix and AMD and Winchip battling for x86 compatibility, and the web browser wars where everyone was trying to be compatible with Mozilla or what the original one was. Has there been, what worked well, what didn't work well?
Yeah, so the question is, are there any lessons that we can learn from the previous incarnations of this problem, like x86 compatibility, POSIX compatibility, browser compatibility, those types of things? I think absolutely. So I think I wouldn't claim to be an expert in this space, but looking at SNIA and looking at previous Plugfests and things like that, I think maybe a major lesson is that doing standardization, doing open standards goes a long way towards this problem. And I think that's really what one of the goals that we're trying to do here is to have some sort of if not a formal specification, a de facto standard or published test suite that you can say, hey, I implement all of the features. So I think that's probably the lesson I would draw from it. I don't know if you have anything to add.
I don't really have too much to add. I do know that there's like some similarity between like BIOS and SQL and other things, C and other things that have taken 10, 20 years to become standards before things get easier. So maybe follow that pattern. I know SNIA has a lot of experience with SMB. It was a similar thing with SMB. I'm not too familiar about that. I can't really talk about it, but it was a similar kind of pattern that we're following. They had a Plugfest, and then Microsoft joined it, and then things took off. So I don't know if we'll do something similar with Amazon, maybe.